welcome to What's New in Electronics 2019. I'm joined on this Smart Supply Chain roundtable by Michael Ford, Adam Fletcher, and Stuart Saunders. Hi guys, thanks for joining me. Now the Smart Supply Chain is another of these terms we like to bring up at events around the world. But to me, it also has connotations of what do we mean by smart? You know, are we talking secure? Are we talking intelligent? Are we talking fast? And it'd be interesting just to pick your brains, so find your take on the current state of affairs. So take us away, Michael.
Yeah, dare we say Industry 4.0, but let's talk about how factories now have to be more flexible than they've ever been before to meet customer demand. That wave of change of business paradigm is coming originally from the customer. Distribution chain has gone now. The factory is feeling the raw demand of customers. They need to change what they make on the fly. And of course their dependence is on materials. So rather than having materials as a batch push process driven by ERP, MRP, and then pushing the materials out to production, the whole thing has been turned around so that you have manufacturing now needing materials at short notice, but having to go out into the market to buy them, no longer under MRP, but to go out and search for materials. And also, you know, those materials that may be available, there is a large issue in whether or not those components are genuine. Because a lot of people who are in search of components at short notice, they don't have time to fully test them. They may be taking them from unauthorized sources because they believe it's worse to leave the customer without a product than it is to look at a material that they may normally not use. So the work that we've been doing is to take the message about material demand directly from the manufacturing floor out into searching for materials, but then to start to create rules by which a secure supply chain can be formed. Now this secure supply chain means that, for example, a material that would arrive for use at the factory would have some form of code which would be guaranteed untamperable code, so that you know that whoever created that package takes responsibility for the content. So there are some rules and procedures around how that works, what the labeling should be, what the packaging should be, how to keep the transactional information using, for example, distributed processing like blockchain, such that when the box is opened, the manufacturer will say, okay, I've got these materials, I can see the full provenance, and even if I'm a high-end military consumer of these products and it's gone through various levels of distribution, I can still be satisfied that these now agree with the mandate that I'm given about where I should buy materials. The whole process should lead to a situation where we can eliminate counterfeit materials, because US military recently said in a report that 15% of their supply chain is suspected to be counterfeit. So this has very quickly become a very, very serious problem. So the smart supply chain has to encompass both of these things. This kind of very short lead time for buying parts that are available and being assurance of the provenance.
Adam, what do you see?
Okay, well, I don't like the term supply chain. Supply chain infers you're locked into it, and if you're a first tier supplier to an automotive company, you're in a chain, but I would suspect that the 99% of all manufacturers in the UK are not in a chain, they're in a network, and they choose to plug into that network or be plugged out of that network. So I think that's a better terminology for this rather than chain. It's a network, because everybody's agreeing to come into it and move forward with it. I think you raise a couple of issues that are fun. I mean, where you're applying Industry 4 and the principles are very different if you're a flow manufacturer or a batch manufacturer, or if you're a very small manufacturer like military type applications. And none of these can move forward without some form of lead time. There has to be a lead time built into the system somewhere. You can't say I'm going to manufacture this now and expect the components to be there, especially for military applications, where the manufacture of a military semiconductor might take 12 weeks to make the component, but you're then going to go through a 3-month burn-in cycle for it to get it qualified to Jan S qualification or whatever it is, or Jan M qualification. So you're never going to be able to, in a military environment, to pull material straight away. You're going to have a lead time on it. And so I think that part of this is planning. How do you plan to get the lead time? And if you're planning that the lead time is going to be around about 3 months or 4 months, whatever that happens to be, and there'll be a big diversity across the components that you're buying. Some will be available very easily, but I suspect some will be on a long lead time, and you're always going to be governed by the longest lead time item as to when you can build. And so that really dictates what you do, and I think if you're giving some forecasting to the manufacturer or the manufacturer's authorised distributor about what you want, and they're now holding inventory for you, and many manufacturers' authorised distributors will hold inventory for you against plans, especially military programs, because military programs don't generally die. They might move forward a few months, or they might get pushed back 6 months, but they're always really there, so they know the material is going to be consumed, and they can then hold that. And the fact that you're buying within the authorised chain from the manufacturer to the distributor, especially with military products where you have very stringent C of Cs, the traceability is already there. I think where you have a more interesting problem is in the high volume manufacture of consumer products, where you're buying products in very high volumes, generally on very short lead times, and you've got to feed this big machine that's running. You can't stop the factory. There, the supply security becomes a little more interesting, and I think there's some technologies that are leading to make that more interesting, such as what's happening with blockchain, which I think will make it very, very much more secure. And I think that will be a really good adaptation. But in terms of where Industry 4 is right now, from our perspective, it's been spoken about a lot. Some companies are trying to implement it, but it hasn't really come on. It's a bit like the autonomous car, great fanfare, but we aren't quite there yet. It's taking a little longer than people expect to get. It will get there, but it's going to take a little longer than people perhaps think. And that's not a bad thing if we get there with very good systems in place. If we've thought the systems through and got systems in place that work, that's a much better system than rushing a system and finding there are holes in it. And the big problem with really IE4 is the security of communication between all the nodes, and that's really where I see most of the problems coming today, talking to customers, is that they'd like to do it, but they're very worried about how do they get all the sensors secure and all the communications secure, and how do they stop anybody getting in and mucking with their system.
Yeah, absolutely.
Just to come back to you on one point, what you talk about, the creation of the semiconductors and the lead time for those critical key components, absolutely true. However, the most counterfeited part, which used to be those chips, is no longer. It's actually the humble ceramic condenser. And even military have been buying these as bulk parts. There's no serialization, there's no special handling, they just buy them in. So there was a fighter aircraft went up, failed to recognize friend or foe, came back down to ground, board tested out perfectly. They checked all of the big chips, as you might imagine, all perfect, and it was the ceramic capacitor. Now, that ceramic capacitor is made in the billions and is used in millions and millions and millions of products almost every day. So the actual breadth of the effect of counterfeit is actually stunning.
Oh yeah, and people are, quite rightly, I agree, they've moved from counterfeiting what I would call expensive components. What you're looking at in the military is very bespoke counterfeiting. This is almost artisan craft counterfeiting, yeah? And I think that's largely been eradicated now. People have been aware of what's happening and think about it. I think the access to internet searching has created a problem because people put searches out there on the web. There's people who look for those and then magically turn up with the goods. So that's not. I think the real problem today isn't that sort of cottage industry counterfeiting. I think it's actually the problem is very sophisticated counterfeiters, and these are quite often factories that have been set up very well, probably by the manufacturer, who then moves off and leaves that factory. And that factory keeps producing parts for them, or producing parts for them. Now, many of those parts are very good. Many counterfeit parts are as good as the manufacturer provided, but they're not good in military applications. Yeah, if they're being stretched outside their parameters. But I can say, if you've got an MP3 player and you've had it a year and it packs up, and you throw it away, it's probably a resistor or capacitor in there that's broken. Almost certainly, it's something very small. But because it's a $5 part, and you're now going to buy another one for $10, and it's got 3 times the memory, you don't really care. That's not the case in public procurement, where you're looking at long in-service life cycles. And for those, you need a much better strategy to control the parts that you're getting. And I think the manufacturers themselves, not only the components but the systems manufacturers, understand that. And I think they're in a much better place than they were before.
Yeah, makes perfect sense. I mean, Stuart, do you think that's a good differentiation there between supply chain and supply network? Supply network makes more sense, doesn't it?
Yes, yeah, and I think people talk about approved vendor lists, and then I think there's definitely, certainly in military terms, you have both an approved manufacturer and an approved vendor, so that because it's actually that you depend on that vendor to actually control their supply network. Probably, and I think both Alan and Michael have made the point that we're on the cusp, aren't we, of the smart solutions, and I was lucky enough to spend 5 years with Rolls-Royce Nuclear, and the level of scrutiny for anti-counterfeit is literally to decap the silicon and take the parts to pieces and have a look at the dies inside them to check that they haven't changed. And maybe another point, I encountered an LED which was counterfeit, and it was perfectly fit for purpose, and the main brand had actually sourced these and badged them as their own, but they were different enough such that they were a problem in our application.
Wow, that's a new
but
one.
But to their own, and this is what's dangerous as well, is when a design, and I say to designers, never ever design beyond the spec of the data sheet, because as soon as you do, and somebody cost reduce the part or messes with it and it still meets the spec, your product they've broken your design, haven't they?
And that mainly happens with analog parts. It doesn't happen with digital parts, because the digital part you generally design to spec and it fires out ones and zeros. It's the analog parts that engineers tend to tweak, because you're looking at a signal and you can adjust that signal or trim it in some way, and those are where they tend to have the problem. But you don't get very many counterfeit analog parts, interestingly.
Because they're so hard to engineer.
Not really, because actually they're actually easy to engineer. The actual manufacturing process to make them is actually easier than the big digital parts, but people haven't chosen to do it.
I've seen many examples, and in fact, I chair the IPC 1782 Traceability Committee, and we've had a lot of stories, and if I were to tell you the stories, I'd be shocked, but I'd also shock you. You'd never fly again, you'd never drive a car. But there are cases that we saw where a reel of components, passive analog components, they had been remade so that on a reel of 1,000 parts, there were 100 good ones, and then every 7th one was counterfeit. Now, the reason for this was to basically conceal itself. So incoming inspection would test the first few parts, and of course they're genuine, so it goes into production. In production, they have a few failures here, there, and everywhere, but it's so random that they can't pin it back to the source. This is the level that we're having to deal with, but this is actually fundamentally destructive for manufacturing, because what we've seen over the last few years is that through trusted supplier networks, manufacturers don't do so much incoming inspection anymore. They don't have to. They kind of have an assumption that the materials are good. And, if they go off-piste and buy stuff from, other people, that's their risk. But if they go through authorized routes, then they should be fine. But from what you said, where even the branded stuff is coming out to be counterfeit, this means that manufacturers are having to do more incoming inspection now, which is a return to the days of 30 years ago. Yeah. It's a significant cost for manufacturing. If you consider that manufacturing, let's say of an Apple device, 1% is a manufacturing cost, 40 or 50% is the material cost. You add then the inspection cost. You're doubling or tripling the manufacturing cost simply by having to do the incoming inspection, where the materials were specifically orientated to fool the inspection process. And so this is why we believe, in fact we've heard all the stories, from so many areas of manufacturing that say they have instances of counterfeit. They have chips with nothing inside. They have chips that are the normal chips that have been modified with additional code which has got spyware inside. I mean, the range of stories that you hear is mind-blowing. And something really has to be done, not only to get rid of the cost that manufacturing and also the responsibility and the safety for the products that people are making in these autonomous cars or aeroplanes or spaceships or whatever it may be. We need to make sure that the supply chain or the supply network, in fact the network is great because that implies the real path of where materials come from, but you have to be able to trust every element of that, and that's where the secure supply chain rules have to come in.
And that's really why we're saying purchase via authorised distribution, because they have a supply chain, a web, a paper trail of where products have gone to and where they've gone from and where they've come back to. And so, but through authorised distribution, there should not be a problem. There really shouldn't. Now, that's not to say that it can't get product in there. And I have seen one or two instances of product getting in there, and what's happened is they've sold product come from the manufacturer, they've sold it to a large contract electronic manufacturer. That contract electronic manufacturer has moved it to one of their other plants in America, for instance, and then they want to return it to the manufacturer. The manufacturer doesn't want to return it back, but he wants it to come back to their authorised distributor. Authorised distributor has to accept that what they're getting is what the manufacturer says it is. They can't test every product, they say put it on the shelf and resell it. Now, we have found instances where those products have been infected, i.e. the CEM has mixed batches, and he's had batches of good product from authorised distributors, but also at their plant in Guadalajara they've bought some product in from the, who've sold that electronics in China, and it's got mixed in. Yeah, and that's very difficult then for us to track it. So I mean, I'm of the opinion that authorised distribution should take no material back.
Yes.
Yeah. I mean, that's the easy answer. Don't take any material back, or only take it from the manufacturer. Because if it went to the manufacturer, they'd have to test it before they could ship it back out again.
Yeah. I mean, would that packaging solution solves that? If an item is packaged with a source that traces it back to the manufacturer.
The trouble with all the if you look at counterfeit products, they are really, really beautifully done. They come in boxes made to look like Farnell. You open it up, it all looks like Farnell literature. You get the reel out, it's got all the numbers on it. They are very, very sophisticated counterfeits.
And that's why you can't trust it anymore. Or you can't trust existing packaging, labelling, or even data in a database somewhere. You can't even trust that anymore. The structure that we've put together is a combination of tamper-proof labeling. Now, there are many different ways of doing that. Holograms, there's 90 different companies doing that. There are people reading surface textures and creating fingerprints, people embedding UV fibers into packaging material, which are guaranteed not to be duplicatable, because you mustn't be able to duplicate that label. And then the packaging has to be such that if there was any tampering, then it's evident. So it's tamper-evident packaging, which already exists in the customs world. We can transfer goods using these kind of mechanisms. But the standardization of packaging and the standardization of labeling, albeit from a variety of different sources, has to be made to reduce the cost. But then you have the final problem, which is where do you store the data? Because it's a fact that pretty much any company that you can name, even the big companies providing cloud services, have all been hacked.
Yes.
So you cannot trust data that's actually in one place. You just can't. People focus on viruses and access and all of this kind of stuff, but it only takes one disgruntled employee in the IT team who has access to everything. He's just about to leave the company. Somebody's going to pay him $10,000 to modify this record a little bit. Fine, I'll do it. It happens all the time.
But that brings the real problem out, Mike. And the real problem is the weak element in all this is the people.
Yeah, exactly.
Because even in the counterfeit supply chain, the brokers and people who are dealing these products know they're counterfeit. These people aren't stupid. They know where they've bought it from. They know that this isn't good. And we've seen examples in the US where they've been buying product, and they're buying it from some very small outfit who obviously knew that this was counterfeit. So I call this masochistic purchasing. Yeah, masochistic purchasing is where people are going out saying, we can get it. I can defeat the lead time. You can't. If the manufacturer's lead time is 18 weeks and there's no stock in authorised distributors, the lead time is 18 weeks, and anybody else who reckons they've got it is lying.
Actually, that's not strictly true, because what we see in those situations is that a company will overstock one part and then sell it through a network to the other party. Both of them are defence companies. So would they trust the parts from a different defence company which they're able to source?
And I see no problem in that, because that's just using goods effectively or using their assets effectively. But they've got to trust that. They have to trust that relationship. So it's just like distributors moving parts between locations.
One to another.
Yeah. So it's the same level of trust.
But if a counterfeit is found, where does the responsibility lie? And this is where the actual kind of logging of the responsibility of components comes in, and that's what we're looking for as part of the standard. Because already we can see in the US there have been several prosecutions, successful prosecutions, where people have been able to say, using the secure supply chain ideas, I can account for who is responsible for putting the materials in this package. It may have gone through various distribution channels, all of which are authorized, of course, but that pinpoints the point of responsibility. And there have been prosecutions such that, where people who are making this ingress possible, where they know they're going to get found out, they will simply have a business case which doesn't work anymore. They'll go off and counterfeit something else.
Yeah. And the big problem is, in the US, the US DOD have fixed it by putting some very, very stringent penalties flowed down to their prime contractors. We don't have that in Europe, and we certainly don't have it in the UK. Yeah, and the penalty for providing counterfeit products in the UK is marginal. It's negligible, even if you can get them. I mean, the chances of actually getting hold of somebody and taking them to court is so ridiculously difficult. And when you get them there, you're effectively taking them for effectively brand or IP theft is about the only thing you can get them on. And the penalties of that are very small, really. It's getting through copyright and other issues. I mean, the example I gave you about the box, the box with the distributor's label on it is a great thing, because you can now prove that was, copied. So you've got intellectual property theft, and then you start to look at the product inside. So you can build a case. But I know of no case in the UK where anybody has really gone for a counterfeit of an electronic component anywhere. I've never heard of one. Yeah, I mean, I've seen some components, but I've not seen anybody actually take them to court.
To court, it's difficult because you can't have that chain of responsibility. That's the key thing.
From a smart point of view, it sounds like this encrypted validation code that goes with components. Is that happening now, or is that yet to?
It's yet to come, and one of the drivers for that is to provide benefit for people like yourselves. I mean, when you receive material, you've got to understand what that material is exactly. Now, the manufacturer designed that material digitally, so that digital information is available somewhere. And there is a new standard from JDEC called JEP 30. That standard allows a component to be digitally modeled in terms of all of the physical characteristics plus electrical and thermal characteristics as well, so that when you read that code, you then get that copy of that authorized, this is what that component is. You can then verify that. Or you can take that data directly into your machines, and you've got a working SMT line.
Carry on now, I'm sorry.
So if you look at the traceability that's already in the system, you've already got the batch, the date code the product was made, you've got the batch code, you've got all those identifiers on the C's of C's, on the boxes, and all that traceability is there already. And people can still forge it, or change it, or you can take the material out and change it. So you're relying on somebody checking it. So all these things can be overcome, and I think that the advent of blockchain might be a nicer way to do it, because you'll be much more transparent. At the moment, if you as the user want to know about that batch and that product, you've either got to go back to the distributor or the manufacturer and ask them for that information, and they will then, reluctantly provide it for you. Whereas if you're a user on blockchain, you'll just go and log your blockchain number on it, and it will show you exactly where those parts have been and where they came and went from. And so I think that does give some greater security for people, and it'll be very obvious if something's moved off and come back or changed in some way, and that's just because it's a public record.
Going back to a point you said previously, often people will knowingly use suspect parts, components, to cut corners or to achieve a lead on their competition. We can supply it before you. How do you legislate against that?
You can't. It's stupidity.
Yeah.
It is stupidity. If you cannot source openly in the market from the manufacturer or the authorised distributor a product, then anything else you do is just very, very, very high risk. And frankly, you're better off putting your hand up and saying, "I'm sorry, we can't build it because we can't get X." Yeah. Now, I guarantee. If you're supplying into a military application, you place your order on this company and there'll be an enormous amount of pressure put on them to, defeat their lead time. And generally they'll try to do that. But you can't always do it just because that cycle of manufacturing, sometimes for military products, is very long. But I would also say if you're a large manufacturer, if Apple stand up and say, "We want this product," and they say, "Sorry, it's 10 weeks, they place an order and I guarantee it soon tumbles down. They may be robbing product from somebody else, but they're going to get the product because they are important.
Exactly.
But the thing that pressurizes people to, you mentioned maybe we shouldn't accept returns and what have you. The thing that pressurizes companies to take that is living with obsolescence, because obviously there's a real shortage then, and you literally are finding the last components that are settling on the planet effectively. But it's nice to hear that the validation code, if you like, carries with it all the attributes of the component, because I'll perhaps talk a little bit now about defence in depth and a strategy, if you like. I think everything should have a strategy in levels, shouldn't it? And if we think that we've done all the right things with the supply chain, probably me being a bit more process orientated, and maybe we go back to the story of the ceramic capacitor that was counterfeit, and the implications are massive, and the contamination level is massive. Automatic optical inspection. So those systems the optics are so good now that actually the system will see a colour change in the ceramic. Yeah. So I think the defence in depth. Let's make sure that all of our inspection systems, which are automatic and smart...
It's a lot more difficult than that, and I'll explain why. You can be the manufacturer of a capacitor and you could be making it in 4 different sites in the world, and the composition of the dielectric that comes out of Japan is going to be different to the dielectric that comes out of Korea, and the colour of the dielectric that comes out of North America, so you can't see it. If you're a semiconductor manufacturer, you may well be making products in different fabs to the same rev, so it's very, very difficult to do it. What I'm just trying to say is, I'm not saying it's impossible, but it's unlikely to be the solution. The solution is to make sure you've got the right product before you put it on the board.
Yeah, I'm seeing this from Stuart's eyes, because AOI and X-ray can identify differences. The JEP 30 standard from JDEC tells you what should be there, and that can carry an X-ray of the die and pick up all of these variances on a lot per lot or even item per item basis, if you know that. And that's why you get that information as part of the code. So what we see, Aegis, we're just a software provider of MES. How are we mixed up in this anyway? It's basically our customers, our manufacturing customers come along and say, we love your traceability. We can understand from the X-ray or the AOI, we can understand this component is different, or we see results in our quality reports that show a particular component was wrong. And we can use traceability that we have with Aegis in manufacturing to pinpoint the incoming package. But after that, it's darkness. Because as you said, everything is labeled, but it could be labeled in a way that's counterfeit. We've seen just enough doubt that you can't find any responsibility. And they said, guys, you need to start to talk to these component networks to make this foolproof. They said, we don't care how you do it, but we want to see it foolproof. We don't want to see anything that can be copied or photocopied, duplicated, anything like that. We need to see something where we open a box of materials, we know it's good to go. And if it's not, we know
And that's
exactly.
where blockchain gives you the advantage, because you've got a publicly available record to look at, and that's the step change I think that we're going to see.
Yeah.
Because at the moment it's all really done on photocopies documents, or documents or copies or,
exactly.
or screenshots of documents, and to be able to look at it online digitally, I think that would be a major step forward for people. But I think, I'm being honest, I think blockchain in our environment is probably 5 years away. To being regularly used by customers.
Yeah, a lot of people have a misconception about what blockchain is, because basically if you're storing data in one place and reading it, somebody could hack into the system and change the value. Nobody would know. With a blockchain, the data is stored in a number of different places. And so when you read the data, it can be like 100 different places come back. And if there's 99 places saying one thing and one saying something else, you know that was hacked, or that is for some reason inconsistent. And so you go with the majority. Now, you're storing the data hundreds of times, so you've got a huge amount of data to be stored, and there's a cost associated with that. So you have to choose, do I want 3 people or 100 people or 1 million people to store that data? The more I have, the more secure it's going to be, but the more expensive it's going to be. So how do I pay for that? How do I motivate companies to provide that service? If it's, for example, a group of companies in the industry, let's say 3 material suppliers, what are the chances that somebody could hack all 3? Possible, but almost impossible. Or what about the gateway between my computer system and the data in the blockchain? Because the blockchain has to get the data back to a point at which it then sends it to you. That is vulnerable too. Right. So you've got this question about cost, and then about the ability to be sure you've got enough people participating. Then you've got the issue about the data size, because if you've got like 100 people, and let's say somebody comes along in our environment and says, we want our traceability data to be stored securely in a blockchain. Well, it's ridiculous, because a blockchain should only be a very, 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 very small piece of data. And that data is often like a hook or lookup into another private database. And there are mechanisms like a checksum or a hash value that ensures that that data has not been tampered with. But the blockchain itself needs to be light and agile and able to store. I mean, you think of it, how many packages of materials are sent around the world every second of every day? And you're talking about a computer system that's massive, especially when you multiply that data out hundreds of times.
Yeah, but I mean, if you look at what companies are doing now, they're already doing that in lots and lots of different bespoke systems.
Yeah, that's right.
Yeah.
So
aggregating it in some way, I think, actually will actually simplify it.
If
I'm
they can
not saying
standardise,
it's absolutely hack-proof, but I think, when companies get together in coalition around things like blockchain, they might think of slightly more useful ways to do the data. At the moment, everybody's sharing that data from their own servers down through all their supply network systems, and their customers and their upstream suppliers are seeing all this data, and they're all maintaining it on their own servers and own systems and everything else. It's very, very inefficient. Whereas with blockchain, you're going to have one carrier data pointing back to one series of records. Theoretically, it should be a lot more efficient. Now, whether it's like all these things, that they look efficient when you look at them. Actually, the implementation may not be quite as efficient. But in theory, it should be.
Yeah.
And that's exactly what we're doing through the generation of this standard, to drive the industry toward this overall standard approach that gives you the guarantees that the customers want.
You can see there will be that defence, aerospace will lead this, because it makes 100% sense that they have to do this.
Yeah.
Well, commercial customers want it as well.
Well,
because
yeah,
they're
but do
making
you think there'll be a trickle down?
I think they'll demand it. In fact, I would think that the commercial customers will drive the demand in front of military aerospace customers, because their potential loss of revenue is huge. I mean, a military fighter plane falling out the sky with 2 people in it, it's a problem. It's expensive, it's not very nice.
But nobody will talk about why, will they?
No, nobody will tell you why.
No.
But you get a bunch of Samsung smartphones with the battery doesn't go, and it sets the thing alight. I mean, suddenly you've got a massive problem.
And everyone's talking about that problem tomorrow, aren't they?
Well, this is the exact problem, because if anybody were to admit there was a vulnerability in their manufacturing or their product, they've got massive potential lawsuits. So you will not hear typically of any stories of counterfeit from commercial companies, actually.
Yeah, and wrongly, in my opinion.
So, and it's really brave of the US military to actually admit that they do have this problem. And I think because they're willing to admit it, that is where it starts. And they have the power to force the adoption of a standard that not just takes care of the paperwork, as all the standards do today, but actually prevent counterfeit ingress. So this initiative we have through IPC is really to break through that and provide, and it'd be great to do a proof of concept with companies. We're now looking for people to do that with, whether it's military or commercial or whoever. The basic conditions are already written, the standard is on its way to being prepared for industry. And we would love to invite companies to participate.
And the whole ethos of IE4 is that you can make it in any of your factories anywhere in the world at any time with a unit size of 1. Now that infers that you've got to be very confident that when the material arrives, it's the right material. Yeah, but you've got to, you can't do it without some form of lead time. Yeah, you've got to get the material to the plant. And so this utopia of no material is rubbish. The material's somewhere. It's just not perhaps at your site. It's in the network somewhere. But and you have to have some ownership of it. You have to have purchased or given some authority to own some of that inventory, because people aren't going to take that inventory for you and hold it indefinitely at their risk. So I think it's all part of planning, and I think that the big companies are very, very good at planning and very smart at how they move stuff around, really. And they're manufacturing at very, very low margins today. Certainly a lot different to when I came into the industry 20 years ago, when margins in manufacturing were real. The China effect has really depressed manufacturing margins down a long way, and we have to find a way in the Western world through technology of being able to try and get our costs down, and that's really the thrust of IE4, is to how to reduce cost.
Yeah, I think that we need to go a little further to change our understanding of how factories are able to plan today. Because the old systems of ERP planning, looking at the sales forecast from customers, are one thing. They almost don't happen anymore. EMS companies literally get approached with a week's notice. They say, can you manufacture this? How much is it going to cost? And it's literally within a week or two they have to be manufacturing it. They have to be able to source the materials very quickly from the network, dependent on the fact that there are stocks available. Because remember, the kind of jobs that people are being asked to do now, it's not 1 million of a product where you would have to wait the lead time for the manufacturer. It's 100 or 10 of a product where those materials are available locally at a distributor. So the whole paradigm of ordering materials is changing as we speak. It's no longer a long-term forecast.
I'd agree, but in military programs it is going to be a long time just because of the qualification. But for commercial products, I'd agree. And for many products, manufacturers can call them in from a authorised distributor anywhere in the world. And in fact, most authorised distributors operate in multiple territories and have their inventory located there. So just in order to fulfil that, and where they don't, they'll quite often put in consignment stock within the contract electronic manufacturer or the customer, so they can pull from that stock as they need it. But there has to be some pre-planning and ownership of that material, and that's the critical. You cannot have a system that says, I don't own it until it comes through my door. We got the ludicrous position a few years ago where large CMs wouldn't pay for material until it finished off the end of their ATE on the line. Then they'd say, okay, we'll accept ownership of it now. Oh, and by the way, 120 days. And that's not acceptable. It is not acceptable. If you want to do it, you've got to plan your material properly and pay for it promptly. If you want the services and the value-added services delivered to you, you've got to pay a realistic price for what you're going to pay.
They don't want that, though. They want to give you as a distributor access to their warehouse where you can store your materials until they need them to use on the line. I didn't know they waited until the end of the product's been made, but certainly the point of ownership transfers at the point where somebody picks the material for use in
I
production.
agree. It should be picked out of the store.
Yeah.
As
So-
it's picked, it becomes theirs.
Yeah, so
and I don't think anybody has a problem with that. But what you have to remember is authorised distribution runs on very tight margins, and holding inventory in known locations,
It's
2 or 3 locations, gives you much better service levels. Yeah, because when somebody comes with an inquiry, you can just pick from that stock. If you've got stock distributed around 100 different plants, you've got to either withdraw it and then send it. So what I'm saying is you're impacting your service levels, and we're trying to do everything at low cost because, like everybody else, we're getting beaten about pricing. It's got to be lower. You've got to do more for less. We're trying to do that, but it's trying to square that circle, and so we're trying to manage it. But I'd honestly, I would encourage, and I can say this all the time, please talk to your supply network, both up it and down it, about what you want. Because if you talk to people about what you want, you'll generally get a much better response than ping an email out.
Well, we've had cases where people want to say, look, we're not going to tell you what materials we want. We're not going to give you any forecast at all. But here's our production schedule. And here's the live information from our manufacturing that tells you what we've built. And so you can then figure out when things need to be delivered to satisfy the next run. So we're giving you a PO to cover anything. Yeah. And you just deliver what we want when we need it. There's no other constraints whatsoever.
And that's fine, because even those blanket orders are covered with some sort of PO, and they're covered with some sort of lead time event. And so the people, and I've worked with these organisations where we're supplying product, and it works very well because we're seeing what happens. But what we can't have is somebody in the planning department says, oh, actually, we're going to pull that lot forward to here, and now you're going to meet it.
Right.
Because you can't do it, because you've now defeated all the lead times.
You've got to have rules in there.
You've got to be rules.
Absolutely right.
And I think I'd say all authorised distributors would gladly work with that system, because when you start to work with it, you get history. Over 3 or 4 months, over 3 or 4 years, you get history of what goes on. You understand what's going on, and that is part of this communication process. You're seeing in and you're talking. Unfortunately, the vast majority of customers say, I want 100 of them and I want them then, and that's what I want to pay for them, or less. And they're not really giving you any real forecast or insight to what they're trying to achieve, because actually what they really need is 10 pieces then and 90 pieces 3 months later. If they told you that, you could probably do it.
Isn't that the opposite of smart then?
Exactly.
It's so sure the reality of the smart supply chain is that thinking of a chain is wrong, because there's connotations of security, reliability, integrity with that just don't fit. A network makes much more sense. And there's a lot of we need to look at different solutions, and a lot of it comes down to responsibility and the integrity of the manufacturer, as well as the manufacturer of the components.
Everybody.
Everyone along the line.
It's a responsibility of everybody, right the way through the supply network, to take ownership of the problem and to fix it. And when they see something wrong, to flag it.
I think we could talk forever about
this. But this, just to finish off, this links with our AI-driven factory of the future, where an AI, we can imagine, is running the planning of manufacturing to suit the customer need. But that AI needs to understand the very rules that you've been talking about. To understand, can I get the materials based on my agreement, based on my understanding? And so it can factor that in and do the communication on behalf of the factory, so that you never get caught short with a crazy demand. Well, you might have the odd one or two where the customers are that crazy, but you should never get to the situation where assumptions have been made that you can't fulfill.
And I think sometimes, you forget that people can work around systems a little bit to help systems.
Help.
And that's sometimes, you forget that in a production environment, you might be stuck for a memory. Well, that memory you happen to know, it says it's built in this plan here, but actually you can pop it in at the end if you need to. Just before test, and you can defeat that 6 weeks. And quite often, people aren't putting all those sorts of, the things that we know in our head. It's very hard to get everything that people carry in their head into intelligence in systems, and that's I think where a lot of the Chinese organisations have been very successful, is they're using their people
Right,
very
yes,
intelligently
yep.
to get things done. They get in a huddle, they figure
Yeah.
out what they've got to do, and they go off and do it very quickly in a very flexible way. And I think that's what we've got to try and replicate with IE4 and do it at a very good cost.
Yes, yeah. Well, thank you for all your thoughts, gentlemen. It's an amazingly complicated and deep subject. Like we said, integrity is one of the main things there, but artisan forges are one of the things I'm going to take away from this. So, thank you for your time, guys. Pleasure
Thank
to
you.
speak to
Thank you.
Thank you.